Alright, so in this video we're going to be talking about SimmerBot. SimmerBot is a machine learning powered trading bot which takes price data and news data, combines them together, generates insights from this, and uses this data to make a decision on whether to buy or sell in the foreign exchange market. So this particular iteration has been trained with the Euro USD currency pair and news data from ForEx Factory. Now, just to be clear, this is not the final form of the project. This is basically the architecture for training and backtesting the model. That's the stage we're at. I mean, the full vision is to get to that point where it's integrated to a trading platform and, deployed to the cloud so it runs autonomously, and simply just have to monitor and, retrain the model over time. All right, welcome to Data Code. We'll talk about AI, machine learning, data science, AI, data engineering, signal processing. Is that an orange? Computer vision. Deep learning, AI, NLP, AI. So I'm just going to go straight into the README for the project. Let me just bring that up here. Just to give like a quick intro. So this is just what I talked about, and then, for the news data, we're actually going to be using an LLM to get the sentiment analysis value. We want to quantify that, right? Right, and just to give you like a bit of a heads up, although we're not there yet, the model is able to, currently do like 8.8% annualized returns, which is not that great, but I mean it's not bad, right? I mean it's positive. If you had just bought and held, you would have been on like a minus 2.6%. That's for the 129 days of back testing that was done on the current version of the model. It returned 3.19% of profit, so it's not bad. It's just not perfect yet. All right, so here's the system architecture. I think I just want to probably open this in a new tab so I can describe it better. Open image in a new tab. How many tabs do I have to open? Jesus. I think this is a better way to go about it. Yeah, just easier to navigate. Photos app works sometimes. Sometimes. Thank you. All right, so start with fetch price data, fetch news data. Of course, you want to clean, just like regular cleaning. Now, just in case you're wondering, price data is fetched with an API using Hot ForEx. I created a demo account to fetch price data. Now, for news data, to build like a custom web scraper for Hot ForEx. That's like a trading news platform. To just collect daily news based on like timestamps and all that. Although, as you'd see later on, the scraping stuff needs to go even deeper, because I just got to the point of like scraping the summary pages of these news articles. But obviously, the large language model explicitly said that there's just not much information in those blobs for it to like make a sentiment decision. So that's like a next iteration type thing to do. So merge the news and price data into one data frame, and then do like the sentiment analysis. And then for the numerical analysis type things, we do like technical analysis indicators, the regular ML stuff, train, test, split, process categorical. Now to compute the target columns, we obviously just have prices, right? But to compute the target columns, we want to predict the highest high for the next 5 time steps, right? So that's what this model is trying to do. So in computing the target column, we sacrifice like the first 5 rows of data, which is small. We have hundreds of thousands of rows of data, and then so it skips through, it checks the next 5. The highest high becomes the target for that row, and then it checks again what's the highest high, and then that becomes the target, and on and on and on and on. All right, and then we want to scale the data and reshape the data for time series operations, because we're looking at 6 time steps of data. So we want to flatten 6 rows of the data into one, such that the entire data for 6 time steps becomes one input for the model to compute in order to generate the target. All right. As you can see here, the train test split and computation of the target is only done during the training phase. Obviously, during testing and validation, we want the model to generate the targets, right? So, good work. Yeah. All right. And then next thing we want to do is that because just think about it, we're working with like 70 something, it's something I don't know, indicators and the regular open, hide, or close, and then you have like 6 time steps. So that's like 900 plus features. It would be insane to have a model with like that number of features. It can work, but I mean, just to make it more efficient, we just want to look for the features that are contributing the most information towards generating the target. So I have this whole feature selection framework, or should I say algorithm, going on here. So we train a bunch of base models, we get the top K features, and then we use a reference LSTM model to see, okay, these top K features, how good are they, right, at predicting the target just on their own without the other sets of features that the model initially would have used here. And then we use the RMSE score, that's root mean square error. Root mean square error. We use the root mean square error as like the basis point for calculating the weight. So do like a weighted scoring. So for each bunch of features, we divide by the RMSE score that they generated across board for all 900 features. So this is just like to generate a kind of equalizer to say, okay, this is the basis point for calculating for each of these models, and then we calculated weighted top K features. That means to balance it out because for a particular model it might be up here, for another one it's like maybe a bit down, and then for the third one it's like, so we want to get that good spot, so we divide through by each of the RMSE scores to say, okay, how much are you really contributing? And then we kind of place it right within that new meta list. So after that, we move on to the final training step. This is now it's like a stack of models because using just one model, each model has its own biases, right? So we want to take the predictions from each of these models, create like a metadata. So it's like the predictions from these models becomes a new data set that we then use to train another model that looks at these different outputs and say, how do they compare to what the actual output should be and what's the relationship, right? So that's a new model. And then finally, we backtest the model. So we take the model here, we have some data that we separated, which the model has not seen before through the pipeline. And then we make predictions on those. And then, trading is like about decision making, right? Stuff like that. So we take those predictions and then we want to see, okay, if the current price right now is like maybe simple stuff, maybe 1.04689, and the model is predicting, oh, we're going to get 1.05689. So it's like, okay, really high. So we're going to take that threshold and say, okay, there's going to be a difference. The market is going to go, the price of the thing is going to go up. So probably want to buy, or if it's like significantly lower, like, okay, this thing is going to tank. So we want to sell. So we get to meet that price point. And then we just optimize the strategy, setting different thresholds, different stop loss, take profit, just a bunch of things like that going on here. And then we generate the report. All right, who wants to see some code? Yeah, me too. Let's go into the code base. SRC, data, price data. Price data is really easy. So we're going to be using MT5, MetaTrader 5, NumPy, Pandas, the usual suspects. So for getting the price data is really easy because we're connecting just directly to the MetaTrader platform and just pulling this data straight up, right? It's not that difficult. Area has like methods that help us to do all these. So you just want to format the date time to match up to what they require for it, and and then just copy rates range. It's so easy. You just give it the symbol, the time frame, start date, end date. It pulls everything for you, right? Super easy. Now fetch n. I, this is not being used right now, but it's more about like for when it goes live. So we're looking at n time frames behind. So we want to fetch all those time frames in order to make the prediction for the next highest high of the next 5 time steps type thing. All right, so this method just helps us to save the data, puts it in a data frame, saves it to a particular directory. Pretty easy. So this is how you'd use this entire magic thing going on here. All right, so for news data, it gets really complex because custom web scraper. Yeah, now another it might be better to use another framework that has an API where you could just pull this news data. That would be like super cool, but this is free. Free stuff sometimes doesn't work like that. So there's a bunch of stuff going on here, but I don't think I want to go too deep. The code is like really self-explanatory, and I designed it in such a way that every method has like a mini documentation thing going on here, so you could just read through the docs to see exactly what each method is doing and how it contributes to the process. So here is just like a summary of everything. Here we're just setting up the web scraping module, that's Selenium, to work with the Firefox browser, setting that up here, and then we load the page, we get all the news entries for the day, and then after getting all the news entries for the day, for each day, we don't want to get all the rows of news, and then for each row, we want to now get the news articles like that. So that's how it goes. So obviously from the beginning of the video, I spoke about how like this scraping is not deep enough. So after getting raw data, there probably needs to be another step, right, which would load the actual article page, not just the summary, and then pull that data into the news rows. But guys, very exhausting stuff. I just like, okay, let's just put this out there. We'll keep building over time. Yeah. And then for the make data set, this is about merging the news and price data. So here's the cleaning, just doing stuff like, sorting the dates, removing empty values, because obviously it's not perfect, right? Some days you have entries that are not useful and stuff like that. So you want to clean up that up, and then because price data always has data, we need to find a method of filling the empty rows of the news data. So how it works is like if we have a news article by 12 p.m. and there's no news till like 12:30, but we have price until then. So the last news obviously is the insight that even a human would use to judge the next sets of price data, right? So we just feed that news, the latest news article forward until the next news article. That's basically what we do. Um, and then to merge the data, I mean, we just want to merge on dates, right? So we resample the news data to fit to the time frame of the price data. So if you're fetching price data, for example, what we have here is every 15 minutes. So we want to then resample that news data so that it fits to every 15 minutes. So if we get news data, if price data is like 12 noon, 12:15, 12:30, and we get a news article by like 12:09, so we want the news article for 12:09 to feed the price data of 12:15 because it happens before 12:15 but after 12 noon, right? So we resample those timestamps to fit into how the price data works, because price data is the one with the fixed structure. All right, so resample, remove duplicates, news timestamps. What we're doing here is at the same time or at almost similar times, two separate articles could come in, right? So we remove those duplicate time steps and just concatenate the two news articles to say, okay, this is the news we have for 12:15 type thing, or between 12 noon and 12:15 we have one news article by 12:07, one by 12:10. We merge both of them as the news article that feeds into 12:15, that type of thing. All right, so we merge the data and then we save the file. It's just a bunch of stuff going on here. So that's all for fetching data. Next, we want to do is to do like the feature engineering, so preprocessing. And for preprocessing, we're doing a bunch of stuff too. Let me see. This is the prompt template for the LLM. So parsing the data frame, we get new sentiment for each article or each set of articles, right? We want to get the new sentiment and stuff like that. So this is more like just the utils file for how everything works. For the technical analysis indicators, you can see a bunch of indicators, a whole lot. It's like it just goes on and on and on and on and on. So that's why if you read the README file, I spoke about how that a highly trained forex expert is required to kind of look into this and say, for this particular currency pair, from experience, which ones are more useful, because you can see we had the whole feature selection thing, but if we're able to feed high quality data that we know is high quality from the get-go, or get another news source that we know actively impacts price information, it just makes it easier to get high quality insights from the data, right? So it's a bunch of these. I'm just going to go back here and minimize because there's a lot going on there. And then we do like numerical preprocessing, encode categorical data. And after we've gotten the sentiments from the news data, we want to drop those articles because the ML model can't read text. And then we do that target creation thing I talked about during the overview of the entire architecture. We scale the values and then we save that scaled data. All right, so during this preprocess pipeline file is where everything then comes together, because preprocessing for training and inference is going to be a bit different. So um, just so this is the order of how it goes. We load for doing training pipeline, we load the data, then obviously there's some tweaks here and there, because so you can choose whether you want to do with LLM or not, because working with the data, each process kind of takes a lot of time, because we're looking at 10 years of data here. So I just made it in a way such that I could do part of the work, save that data, come back later, just set a few flags to say, okay, no, we've done this, let's pick up with this. All right, because if you want to run the pipeline just full on, it's probably going to take about 24 hours, because there's just a lot of things going on. All right, now that's for getting the data and preprocessing. Now for inference generation, it's much faster, and like if we're talking about real-time data ingestion and stuff, much faster, but just because of the volume of data. All right, so we preprocess, train, test. So you can see here, because of the difference in how we're working with things, we set the training flag to false when we're doing for test data and validation data, so as to skip the target generation and some other stuff that would make it reverse of the case of what we want to achieve, which is to get the model to learn, or to tell us what it has learned, rather. All right, and then I talked about this also, reshaping the data to look like to get the previous time steps and everything into one row. So that's what prepared time series data is doing. Like I said earlier, you could also just read the quick docs that I've added to each method to understand what's going on, even if you can't immediately make sense of the code chunk. All right, so for inference preprocess, I have like a different thing going on here. For example, one difference here we can see is that obviously it's not loading a file from memory, because we're expecting it to be like an online real-time process. So it's going to take a data frame. So after you've scraped and merged, you just feed that data frame straight to the inference preprocess pipeline. It's not looking for stored files. So it's just going to do the parse data frame. This is where a lot of the LLM stuff and organizing early preprocessing things are going on. And then we add the indicators, and then numerical preprocess, which is what we do like scaling and things like that. And then prepare time series data, we reshape it. Then we return that data, which the model will then pick up and then make predictions on. All right, so that's basically it. Build features is just, build features. Nothing serious going on here. All right, so that's all for features. Now for models, we have train model. So under this train model module, we have two things going on: feature selection and the actual training process. Now, feature selection, there's a whole lot going on here, but I'll just focus on this run method, which kind of describes what the entire pipeline is doing. You could open up the repository and look at each exact step to see what's going on. As always, lots of explicit documentation so you can understand what's going on. All right, so we train the different models like you've seen from the architecture. We train those models. We get the RMSE score for each one, and then we do the weighted features. We get the weighted features list, and that's what we save to memory. And then that weighted features list is then fed during the. So this is like all the implementation of all those methods, right? That were put in that run method. It generates a report also. And then here we have the actual train stacked model, which does the real training of the stack, like it says. Um, so we get X and Y. So within this get X and Y, we actually filter out based on the top K features. So we just have data that has been deemed necessary for training the model from the feature selection process. And then train stack, basically, it looks similar to the feature selection process, just that this is like way more direct. We train the three different models, and then here we split the data again because remember I talked about backtest data, which is supposed to be data that we've not seen before, right? So here it creates a portion of the data which will not be going um, into the first layer training process and the meta model training process. So this separate set of data is then what we're going to use during the back testing phase of the data. So it's a subset of the test data of the main, like, okay, look at this. We have the main test data. Then we take most of the test data, but we leave a little chunk just for back testing because you don't need so much data for back testing. It's like we just want to see how it's performed, maybe like over a month, 3 months, 4 months type thing, right? Because naturally in the real world, you probably want to retrain your model maybe every quarter and stuff like that, right? So that's the rationale behind this. All right, top. That's basically it here. And then predict model. So this is like the pipeline for using the model to make predictions, right? So um, stack predict, you give it the data, it gets the layer output, makes predictions on the data, and then obviously because we're now making decisions based on the real values in the market, we have to do inverse scaling because we already scaled the data before to make it easier to train the model because machine learning models like values between 0 and 1. It's just easier for them to work with. So scale everything between 0 and 1. And then here we're now scaling that value back into the actual stock price data value that is supposed to be after making a prediction. So simple stuff here. Load the model, scalar, just some helper methods here to make everything work properly. And so that's basically it for models. Utils is just stuff around logging and things like that. And then the backtest module. So backtest utils. So what backtest utils does is, we have to make predictions in real time, right? So it takes the backtest data. Now, okay, so something I did here was just use like a kind of logic here. It's like we know that the backtest data is like the last set of data. So we just take the length of that backtest data from the bottom up because the data is aligned chronologically. So we just use the index length of the backtest data, because we want to actually test the integrity of the model from making predictions from raw data up to making the trade, right? So it looks like doing the same thing twice, but yeah, okay. Um, Now there's a cool thing here where it's like if you have preprocessed before, because it's like a long process. I just put something here that helps me to load um, the, the previous data that has already been preprocessed, because can't be wasting time when you're trying to like iterate and figure out bugs, right? So, and it still helps because I mean, obviously you could do that also. Maybe if you want to like do something else that's not like fixated on the preprocessing aspect of it. All right, and then here is the actual backtest model script. So here I'm using the backtesting module backtest.py. It just makes everything easier, right? Very funny documentation they have here. Okay, cool. Um, so you can set the price. Oh, sorry, did I say price? You can set the starting equity, your leverage ratio, commission, so it's real. So it's like certain commission makes you actually know what's going to be, because brokers will ask for commission. So you don't want to like fool yourself into thinking you're making money when for each trade you're paying commission. So it actually factors in everything like it would in a real trading scenario. All right, and then I talked about the different factors we're optimizing. So we're going to be changing. So close days is like, sometimes some trades want to just linger because maybe the market is going sideways. So it's like you want to check, okay, do I want to close a trade that's not closing within 1 day, within 2 days, 3 days, right? So talk about that. Um, Stop loss percentage. So what percentage price difference do you want to use for stop loss, take profit? What should be the buy threshold? Like how many percentage of difference between the current price and the predicted highest high for the next time steps do I want to use when buying or when selling? So it runs several iterations. Currently with this setup, it does about 3,200 iterations to find the best set of parameters for which to use in making the trade. Now, this is also where expert knowledge can come in, because um, in making this trade decision, which here is the actual strategy um, script, right? So in making the decision, a trader who understands the maybe Euro USD market can say, okay, aside from the model predicting the next highest high, we want to get a proper signal for when to trigger the buy-in. So maybe do we want to do like an EMA crossing strategy, or an SMA, exponential moving average EMA, or simple moving average SMA, or some sort of um, experience-based triggering condition to say, okay, we need to see these setups before we know that, oh, the market actually wants to move, or it's actually just going to be like a choppy market where it wants to just go up or maybe go down, touch your stop loss, and then bounce back, those types of things, right? So overall, that's where we're at. And so everything gets saved here to report. So for the feature selection phase, you can see and it's a slight error from one of the previous runs. Probably have to run that again. So ideally, it would return the top K features which were selected, and then the initial count of features here you can see was 945, and then it gives you just like basic stats, the RMSE scores, training times, and stuff like that. And then over for the stack model, okay, so you can see this one works properly. So these are the features which it used to make predictions. And so you can see here, so T stands for the current timestamp. So you can see for some parameters, it uses information from 2 time steps behind, just stuff like that. T minus 1 time step behind. So not the model itself determines what it wants to look at within that time frame that you've given it. Looks at it, say, okay, this informs, and it brings all that together. Right. And then we can see the backtest stats here. I'm just going to do rainbow line. Okay. All right. So these are the backtest stats, and it's like a lot of statistics here that you can look at: profit and loss, yada 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 yada, stuff like that. The trade duration. So now also like as a trading expert, you can come in and look at these parameters, and it gives you like real insights to say, okay, this is where the model is getting it right. This way, because I don't have that like deep domain knowledge, admittedly. Admittedly. Next, we move to the main.py file, which has the entire pipeline from start to finish, right? So 8 stages in total: fetch price, fetch news, clean news, merge news and price, yada yada yada. So we just have everything aligned here. So it fetches the price, and we have a config file here, the symbol, time frame. Now the time frame only supports minutes, so from 1 minute up to 30 minutes. You could play around with that if you want. You could change the start and end dates for the amount of data you want to fetch. And then during the sentiment generation for the backtest, you want to choose whether to use actual sentiments or mock sentiments. Because in like the reason why I did that was because in this case, like I said, the news data wasn't really adding so much value, and the sentiment generation process, because you use an LLM, is resource intensive. So I just kind of mocked that out of it, since that would still be filtered out later in the pipeline of the inference generation process. Okay, so you can set those up here, and then also for the scraping process, you have to create this .m file. Now I don't want to open this .m file because you're going to see my login details. I don't want you to see my login details. Haha. Yeah, nice try, Didi. All right, so you could have that from here. I've done a sample of it, which you can see here. So you want to create that .m file, and then you could literally just copy this like so. Just copy and then add your own login ID, your password, and the server from your broker. I used hot ForEx. And then just for completeness, I could also show you aside, these are the log files, right? It logs for data fetching, preprocessing, the pipeline, and then there's the main pipeline, and then the model training also. So here are samples of the log files. Oh yeah, they're not on the repository. So here are samples of what the log files will look like. So whenever you see WebDriver configured, just know it's trying to retry, because these websites have like blockers, right, for scraping. Yeah, so sometimes you have to refresh the scraping um, module and then re-scrape that page in case the data is like corrupted or just not working, type of thing. Data preprocessing. So you also want to see what is going on. So it just kind of like keeps you updated, and then if there's any error, you'll be notified, stuff like that. Then for the main pipeline too, so you can see it just gives you like an understanding of what's going on, and then by the time it's completed, it tells you. So now this is 9 minutes because I just tested stage by stage. Like I said, these things take time, so I was just like testing stepwise and then flagging them off, right? For the model training, same thing. Just gives you a sense of what's going on. So some errors here from when I was still debugging was really handy in the debugging process also, because I could see like what errors are coming on without having like a messy terminal. Yeah. All right. So that's basically how this works. To be honest, I'm just gonna go to the README here. So here is also the full project plan. Let me see. It's on the repository too. You can check it out. So this is like the full project plan. So where we're at is here, back testing. So stuff that's left to do is like model optimize. Why the fuck is this thing? Model optimization, real-time integration, deployment and monitoring, continuous maintenance, right? Now here's the README. Now I'd love to. Where's the README? Yo, confusing stuff. All right. Okay, preview README is here. Glory to God. So I just want to do something quick here. I'd love to give a quick shout out to these guys, Yunzi, Lee, Yananji. I don't want to. You could check out the paper. So that's why I got like the insights on how to come up with like the feature selection, the model stack, and the technical indicators to use in this whole process. And ChatGPT helped me come up with the project plan, like the elaborate one with like plenty English in it, right? So that was like a ChatGPT type thing. All right, so back to the repo. Everything is here. Everything's here. You probably want to check it out. These are step-by-step instructions for how to set it up on your local machine. You need to have Python 3.10, Windows, MetaTrader, Ulama, and Firefox, as well as other requirements, dependencies that are explicitly stated. So it's quite straightforward. If you just follow these steps step by step up until this point, you'd have replicated this project here. And then so here's like the description. This is the workflow, and then here are the dependencies I was talking about. So everything is detailed here. And so what are some of the possible improvements that we could possibly have? Unit tests. Yes. Although admittedly, some of the functions are like doing like 3 things at once. So if you want to unit test, it comes with refactoring. You have to refactor the code because ideally each function should do one thing. I know. I know. All right. So we can modify the architecture and hyperparameter tuning of the different models, because you can see we have like 1, 2, 3, 4, 5, 6, 7 different models. So there's a lot to play around with there, from feature selection up until the actual model stack. Higher quality news data, or probably just getting to the final stage of the ForEx factory news data might make it better. Fine-tuning the sets of technical analysis indicators used, fine-tuning the trading strategy, and then now this is more like just progress type of improvement, integrating with the trading platform and cloud deployment. All right, version history, no releases yet, so, but I mean, it's there, release history. Acknowledgements, the paper like I said, and ChatGPT like we all have. All right, so if you would love to see more videos like this, I want you to like and subscribe. I know I haven't made videos in such a long time. It's because I went from freelance to like full on 9 to 5. It's been like this, but I'm starting to get my balance once again, and slowly easing into content creation again. So this has been like my major project for the year. I mean, that's crazy, right? But I started in like October, late October type thing. Started with like majorly just reading papers to kind of like get a good sense of what's required, and then from like November-ish, towards the end of November, took like PTO and then started working on it like heavy, maximize this the festive period, Christmas, New Year. Got a lot of stuff done. So let me know what you think in the comments. If you have any questions about any particular parts of the code, and if you're like a Forex trader and you think that this is something we should jump on together to improve, you have ideas flowing in your head already of how we could make this better, hit me up. My socials are here on the YouTube page, and even in the repository. You can hit me up on X, LinkedIn, Instagram, GitHub, YouTube, OnlyFans. I'm not on OnlyFans. All right. Yes, thank you so much. See you on the next one. Ciao.